Hey, hi everyone, welcome back to this video series on Windows Server 2016. Managing WFAS with group policy. Managing firewall rules on your servers and clients can be a huge step toward a more secure environment for your company. This technology is enterprise class and free to use since it's already built into the operating systems that you use. The only cost you have associated with firewalling at this level is the time it takes to put all these rules into place, which would be an administrative nightmare if you had to implement your entire list of allows and blocks on every machine individually. Thank goodness for a group policy. As with most settings and functions inside the Microsoft Windows platform, setting up a firewall policy that applies to everyone is a breeze for your domain joint machines, or maybe you break it up a little bit and have a GPO that applies firewall rules to your clients and separate GPO that applies firewall rules to your servers, or however you see fit. But the point is you can group many machines together in categories, create a rule set for that category just once, and automatically apply it to every other machine by making use of group policies' powerful distribution capabilities. You are already familiar with creating GPOs, so go ahead and make one now that will contain some firewall settings for us to play with. Link and filter that GPO accordingly so that only the machines you want to have these settings will actually get them. Perhaps a good place to start is a group of test machines so you can make sure all of the rules you're about to place inside the GPO work well together with all of your other existing policies. Once your new GPO is created, right-click on it. From the inside, click the Group Policy Management console and click on Edit. Now that we are looking at the insides of our new GPO, we just need to figure out where the correct location is in order for us to create some new firewall rules. As when you are looking inside the rules on the local machine itself, everything is listed under a firewall, Windows Firewall with Advanced Security heading, and that is located at Computer Configuration, Policies, Windows Settings, Security Settings, Windows Firewall with Advanced Security, Windows Firewall with Advanced Security. As you can see, this is also the place to go when you want to make sure that particular firewall profiles or the Windows firewall as a whole are specifically turned on or off. So this is the time that you would go if you wanted to disable the Windows firewall for everyone by clicking on the Windows Firewall Properties link shown earlier. You can determine the status of each firewall profile individually. Once you are finished setting your profiles according to your needs, click on OK, and you find yourself back at the WFAS part of the GPO. Just like inside the local WFAS console, you have categories for inbound rules and outbound rules. Simply right-click on inbound rules and click on new rule in order to get started with building a rule right into this GPO. Walk through the same wizard that you are already familiar with from creating a rule in the local WFAS console, and when you are finished with your new inbound firewall rule is shown inside the GPO. This firewall rule is already making its way around Active Directory and installing itself onto those computers and servers which you defined in the policies, links, and filtering criteria. Encryption technologies, an idea that has taken a first step from something the big organizations are playing around with to everybody needs it, is the use of encryption. Most of us have been encrypting our website traffic for many years by using HTTPS websites, but even in that realm, there are surprising exceptions, with a lot of cheap web hosting companies still providing login pages that transmit traffic in clear text. This is terrible because with anything that you submit over the internet, now using regular HTTP or an unencrypted email, you have to assume that it is being read by someone else. Chances are you're being paranoid and nobody is actually intercepting and reading your traffic. But you need to know that if you are accessing a website that says HTTP in the address bar, or if you're sending an email from any of the free email services, any data that is being entered on that web page or in that email can easily be stolen by someone halfway around the world. Data encryption is an absolute requirement these days for corporate information that needs to traverse the internet. Though at the same time, I say that the back of my mind is telling me that the vast majority of companies are still not using any kind of encryption technology on their email system. So that is still a potential disaster waiting to happen for most. While we are getting better and better at protecting internet browse traffic, we are traditionally still not paying a lot of attention to data that is safe within the walls of our organization. The bad guys aren't dumb, though, and they have a very large toolbox of tricks to socially engineer their way into our networks. Once inside, what do they find? In most cases, it's a big free-for-all. Get a hold of one user account on one computer and you've got keys to a large part of the kingdom. Fortunately, there are several technologies built into Windows Server 2016 that are designed to combat these intrusions and protect your data even while it sits within the four walls of your data center. Let's look at some information on them so that you can explore the possibility of using these encryption technologies to further protect your data. BitLocker and the Virtual TPM. BitLocker is a technology that has become pretty familiar to see on our client systems within corporate networks. It is a full drive encryption technology, giving us the advantage of making sure our data is fully protected on laptops or computers that might be stolen. If a thief gets his hands on a company laptop, claws out the hard drive and plugs it into their computer, the entire volume is encrypted. This makes all kinds of sense for mobile hardware that could be easily lost or stolen. But in the beginning stages of this technology, the server side of the equation was never really a consideration. With our new cloud mentality coming into play, suddenly makes more sense to want BitLocker on our servers, more particularly when talking about the cloud. What we really want is BitLocker on our virtual machines. Whether you're storing VMs in a true cloud environment provided by a public cloud service provider, or are hosting their own private cloud where tenants reach in to create and manage their own VMs without the possibility of encrypting those virtual hard drives, the VHD and VHDX files, your data is absolutely not secure. Why not? Because anyone with administrative rights to the virtualization host platform can easily gain access to any data sitting on your servers, hard drives, even without any kind of access or user account on your network. All they have to do is mount your virtual hard disk on their system and bingo, they have access. This is a big problem for data security compliance. Why has it historically not been feasible to encrypt VMs? Because BitLocker comes with an interesting requirement. The hard drive is encrypted, which means that it can't boot without the encryption being unlocked. How do we unlock the hard drive so that our machine can boot? One of two ways. The best method is to store the unlock keys inside a trusted platform module, TPM. This is a physical microchip that is built right into a computer. Storing the BitLocker unlock key on this chip means that you do not have to connect anything physically to your computer in order to make it boot. You simply enter a PIN to gain access to the TPM. On the other hand, if you choose to deploy BitLocker without the presence of a TPM to unlock a BitLocker volume and make it bootable, you need to plug in a physical USB stick that contains the BitLocker unlock keys. Do you see the problem with either of these installation paths in a virtual machine scenario? VMs do not have a TPM, and you also have no way of plugging in a USB stick. So how do we encrypt those VMs so that prying eyes at the cloud hosting company can't see all my stuff? Enter the virtual TPM. Brand new in Windows Server 2016, we now have the capability of giving our virtual servers a virtual TPM that can be used for storing these keys. This is incredible news and means that we can finally encrypt our servers, whether they are hosted on physical Hyper-V servers in our data center or sitting in the Azure cloud. Shielded VMs, BitLocker and the virtual TPM are the secret sauce that enable this next piece of technology that is also new in Server 2016, shielded VMs. I'm going to leave all the details about shielded VMs for a later chapter that is focused on all things Hyper-V, but let's just say that you're going to want all of your virtual machines to be shielded from this point forward. Encryption file system. The encryption file system, EFS, is a component of Microsoft Windows that has existed on both client and server operating systems for many years, where BitLocker is responsible for securing an entire volume or disk. EFS is a little more particular. When you want to encrypt only particular documents or folders, this is the place you would turn. When you choose to encrypt files using EFS, it is important to understand that it needs to use a user certificate as part of the encrypt-decrypt process. And so the availability of the internal PKI is pretty key to a successful deployment. Also important to note is that the authentication keys are tied to the user's password. So a fully compromised user account could negate the benefits provided by EFS. I think that many companies don't employ EFS because you are leaving the decision on what documents to encrypt up to the user. This also means that you're depending on them to remember to do the encryption in the first place, which means that they will have to understand the importance of it in order to make it worthy further time. I wanted to mention EFS because it is still alive and is still a valid platform for which you can encrypt data, but most administrators are landing on BitLocker as a better solution. Lack of responsibility on the user's part and a good centralized management platform do put BitLocker a solid step ahead of EFS. Both the technologies could certainly coexist, though keeping data safe at two different tiers instead of relying on only one of the data encryption technologies available to you. IPsec. A lot of the encryption technology built into operating systems revolves around data at rest. But what about our data on the move? We've talked about using SSL on HTTPS websites as a way of encrypting web browser data that is on the move across the internet. But what about data that is flowing through a web browser? And what if I'm not even concerned about the internet? What if I'm interested in protecting traffic that could even be flowing from point to point inside my corporate network? Is there anything that can help with these kinds of requirements? IPsec is a protocol suite that can be used for authenticating and encrypting the packets that happen during a network communication. IPsec is not a technology that is particular to the Microsoft world, but there are various ways in Windows Server 2016 that IPsec can be utilized in order to secure data that you are shuttling back and forth between machines. The most common place that IPsec interaction shows up on a Windows server is when using the remote access rule. When configuring VPN on your RA server, you will have a number of different connection protocols that the VPN clients can use to connect to the VPN server. Included in the list of possible connection platforms is IPsec, IKEV2 tunnels. The second remote access technology that uses IPsec is direct access. When you establish DA in your network, every time that a client computer creates a direct access tunnel over the internet to the direct access server, that tunnel is protected by IPsec. Thankfully, the remote access management console that you use to deploy both VPN and direct access is smart enough to know everything that is needed to make IPsec authentication and encryption work, and you don't need to know a single thing about IPsec in order to make these remote access technologies work for you. The big missing factor with IPsec provided by the VPN access role is traffic inside your network. When you are talking about VPN or direct access, you are talking about traffic that moves over the internet. But what if you simply want to encrypt traffic that moves between two different servers inside the same network, or the traffic that is flowing from your client computers inside the office to their local servers, also located in the office? This is where some knowledge of IPsec policy settings comes in handy, because we can specify that we want traffic moving around inside our corporate networks to be encrypted using IPsec. It's just a matter of putting the right policies into place. Configuring IPsec. There are two different places that IPsec can be configured in a Windows environment. In a Microsoft Windows environment. Both old and new systems can be configured with IPsec configurations through the traditional IPsec security snapping. If you are running all systems that are newer, like Windows Server and Server 2008 and above, then you can alternatively employ the Windows firewall with advanced security for setting up your IPsec policies. WFAS is the most flexible solution, but isn't always an option depending on the status of legacy systems in your environment. First, let's take a glance at the older IPsec policy console. We will start here because the different options available will help to build a baseline for us to start wrapping our minds around the way that IPsec interaction works between two endpoints. There are three different classifications of IPsec policy that can be assigned to your machines that we will encounter in the console. Let's take a minute to explain each one, because the policy names can be a little bit misleading. Understanding these options will push you a step ahead for understanding how the settings inside WFAS work as well. Server policy. The server policy should probably be renamed to requester policy, because that is really what this one does. When a computer or server makes a network request outbound to another computer or server, it is requesting to establish a network connection on these requesting computers, the ones initiating the traffic. That this is where we tell the server policy to apply. Once applied, the server policy tells that computer or server to request IPsec encryption for the communication session between the initiating machine and the remote computer. If that remote system supports IPsec, then the IPsec tunnel is created in order to protect the traffic flowing between the two machines. The server policy is pretty lenient though, and if the remote computer does not support IPsec, then the network connection is still successful but remains unencrypted. Secure server policy. The difference here is that the secure server policy requires IPsec encryption in order to allow that network communication to happen whatsoever. The regular server policy that we talked about earlier will encrypt with IPsec when possible, but if not possible, it will continue to flow that traffic unencrypted. The secure server policy, on the other hand, will fail to establish the connection at all if IPsec cannot be supplied between the two machines. Client policy. The client policy needs to be renamed to response policy because this one is on the other end of the connection. The client policy does not care about requesting an IPsec session. It only cares about receiving one. When a computer makes a network request to a server and that computer has the server or secure server policy, so it is requesting IPsec, then the server would need to have the client policy assigned to it in order to accept and build that IPsec tunnel. The client policy responds by allowing the encryption to happen on that session. IPsec Security Policy snapping. The original console for manipulating IPsec settings is accessed via MMC. Open that up and add the IP Security Policy Management snap-in. Interestingly, when adding this snap-in, you will notice that you can view either the local IPsec policy of the machine which you are currently logged in, or you can open the IPsec policy for the domain itself. If you are interested in configuring a domain-wide IPsec implementation, this would be your landing zone for working on those settings. But for the purpose of just sticking our head in here to poke around a little, you can choose the local computer in order to take a look at the console. Once inside, you can see any existing IPsec policies that might be in place, or you can start creating your own by using the Create IP Security Policy action available when right-clicking on IP Security Policies. Doing this would invoke a wizard, which we will walk through the configuration policy, your IPsec policy. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing, and subscribing. Thank you.